All right. Hello and welcome to our final lecture for text analytics. This week we're going over topic modeling or unsupervised learning. I'm going to be off camera today. I am still recovering from whatever summer cold is going around. Wear a mask, stay home, all of that fun stuff still. It is not fun. Um, this topic is honestly pretty short and it's really more of an art form than a science. So it is one of my favorites. It's the topic that I actually use for a lot of my research. I actually just finished a paper that I hope to submit to a journal soon. So hopefully you have fun with it too. So it's called topic modeling. It's in I keep saying topic, it's in the criteria, the section of unsupervised learning. So last week we did supervised learning, predictive analysis. This time we're doing unsupervised learning. So our data is not going to be labeled. We are going to take it and we're going to try to find patterns. Our learning objectives for this week, we are going to describe topic modeling and how it differs from basic term frequencies. And we're also going to implement topic modeling to discover patterns in textual data. So pretty short and sweet. I leave this one for last just because it is more complicated. It makes sense to kind of leave for last. But it is truly one of the most fun parts of text analysis. So I do hope you take your time with this, implement it into your final projects because it's, like I said, it's a good one. So hopefully you enjoy. So we look at unsupervised learning. So again, last week we did supervised learning. We have a specific thing we want to predict. For example, last week's homework, we did real and fake news. So our goal was to predict of labeled data, how do we figure out which one's fake and real? And then how do we implement that model on new data? In this case, we are taking data and instead of predicting something specific, we're trying to figure out what's kind of going on behind the scenes. What patterns can we find? And this is really similar to unsupervised learning in other classes like predictive models. I'm sure you've had this. You may have used a method called k-means clustering, very, very similar to topic modeling. In this case, though, we are using text. So again, we're finding patterns. We can also classify documents that are not labeled because if we're grouping similar documents together, we are often going to end up classifying documents, even though our goal wasn't exactly to classify them, or we didn't have a label already that we wanted to classify them. And then we can also describe a corpus more effectively. So almost summarize text efficiently by understanding what are some of the groupings behind the scenes. And this is actually a slide I used when I was describing some of my research because it can be hard to understand at first. So bear with me. We're talking about topic modeling. So topic modeling, topic as in the subject of what we're talking about, and modeling, we're trying to establish a framework, what's going on in our corpus. And it's an unsupervised approach to document classification. It's unsupervised because we as the supervisors are not using labeled data. We're not telling the machine, here are all the labels, now go find the pattern. We're saying, hey, we think there's a pattern here. What do you see? And then it's document classification, again, because even though we're not using a classification model, we're not trying to predict a specific category. By understanding what topics are covered in a corpus, we can also understand for a specific document in our corpus, which topic fits best. So this is an example. The research I do is with nonprofit jobs. And what I did was look at job postings. So I would see a job posting for a nonprofit organization. It had a role title, and then there's a big long description. And if you've read job postings, you know that that description is going to talk about the company. It's going to talk about the role. It's going to talk about how to be successful. It's going to talk about quite a bit. And topic modeling is going to go through and read some of these words and phrases, and it's going to say, these kind of words make it seem like a management role, and this makes it seem like customer service, but these words are really used for this kind of thing. And it's going to do that for all of the documents in our corpus. And by the end, it's going to be able to tell us, here are the different topics within your data set, your corpus, that exist. The end result is a listing of all of the available topics. And then from there, we can then go and classify our documents. Now, I will tell you, if you're using Orange, I have not yet figured out how to go back and classify your documents, so you will not be asked to do that. In Python, you can do that pretty easily. So go back and say, okay, this one was a little bit of management, a little bit of customer service, a little bit of this. Which one is it mostly? Which one is best fit? If you do figure it out in Orange, let me know. I'll give you some extra credit or something. But yeah, that's topic modeling. Take our entire data set and figure out what topics exist, what subjects, what themes exist within our corpus. So there are two really common topic modeling techniques. The first one is non-negative matrix factorization, NMF. And the other one is, oh, I'm so bad at pronouncing this one, latent Dirichlet allocation, LDA. So LDA is probably the most popular method right now. It's gaining popularity. I still really love NMF, and it's the one that's going to be in, for anyone using Python, that's the one in the code this week, because it is the one that for me is the quickest, it's the fastest, and has the easiest results to interpret. LDA is a solid one. I just didn't want to overwhelm anyone with too many methodologies, so I just picked one, and I'm leaving it with NMF this week. So if you are really interested, you're welcome to look into a few. But these are the main ones. And again, we're using NMF, non-negative matrix factorization. And the quick of why it's called that is essentially that that sparse matrix we're creating with our text data set, where it's got the ones and zeros and most of it's blank. We're taking that, and if you remember back to linear algebra, if you've ever taken that, we are subsetting our data. We have a length and width, and the two parts are non-negative, hence the name. I probably did a really poor job of describing that, but I don't want to get into too many details because it gets very boring very quickly. What you need to know as future managers of data scientists, as honestly, even as data scientists yourselves, you probably won't need to know the ins and outs of both of these algorithms. You'll need to know the basics of them, and you'll need to know how to implement them. So that's the basics of NMF, and I will show you how to implement them in a moment. Some key considerations for topic modeling. Does your data fit your research question? So for some of you, this fits very, very well. I'm thinking of a few of you are using review data sets, so Steam reviews, movie reviews. We've got a hotel review data set this week. Topic modeling fits very well because if you think of reviews, not all of the reviews are going to be about the same thing. For example, in our hotel example, some of them are going to talk about the staff, some of them about the room, some of them more specifically about elements of the room, maybe cleanliness or the location of the hotel itself. Many of them are going to talk about different things, and that's likely to come up in topic modeling. Sometimes our data isn't quite fit for topic modeling, though. I tried to use our BBC News data set for this week as a practice, and I found that the text was too short, and short text doesn't do too well with topic modeling just because there's not enough words to pick from. So it's really hard to figure out a topic if there's not really a lot of words that the topics or the documents could fit in different topics. What metrics should you optimize for? Now, if you remember back to predictive models, and if you don't, that's okay. Just do a quick search of k-means clustering, and specifically, how do you figure out k? That is one of the big questions I ask data scientists every time I interview them for a job. How do you figure out k? You have to balance out the statistical need of your model with the business needs. If you're trying to cluster data and you figure out statistically the best way to cluster, for example, a marketing data set is into 27 different clusters. But your marketing team says we realistically can only deal with 4 different marketing treatments. That's all we can handle. You're going to have to go with a smaller number of clusters, or in this case, topics. We don't have the resources to handle all 27 different scenarios, so let's whittle that down a little bit and look at what we can actually handle. And does our research question still fit what we can do? And that goes along with the third point. How many topics do you need? We want to balance the business need with the research question with the statistical output. And I don't get into too much detail on the statistical output this week. You're welcome for that. It can get pretty brutal. But essentially, we want the topics to be coherent. So we want the documents within each topic to be as similar as possible, while we want the topics to be as different as possible from each other. So if you picture that, we want, I always picture this out in space. We want all of the topics going out there. We want them in way different parts of our canvas. So we want all of the topics to be very separate from each other. But within each topic, if we zoom in on a topic, we want all of the documents to be very close together because they're similar enough. So this week, if you are using Orange, it is very, very simple this week. You are in luck. You just have to do your normal file, corpus, preprocess, and then you can connect topic modeling, and that is it. Now over here, you can select which type of model you want to use, and you can use whichever one you'd like. Like I said, NMF and LDA are the most popular ones, but you can choose whichever. Just make sure you specify in your homework which one you use. And when you get an output, it's going to look just like this. So topic 1 through however many you chose, and you get to choose, and the keywords. Now, these are not the most common words, but these are the words that made the topic what it is. These are the words that are the key, how do I want to phrase this? The most impactful words to the topic, the words that make the topic that topic. So it's like what makes you unique from other people. Say England, World Cup, that's what makes that topic different. And now the next kind of fun step in topic modeling is that we don't leave these topics as topic 1 or these keywords. We actually end up naming each of these. And this is where it gets kind of fun because you can look at this and say, okay, say probably should have been added to stop words. That's okay. England, World Cup, get final record. This is obviously sports, right? So topic 1 is sports. Topic 2, election, trial, BBC, party. This is going to be politics. Topic 3 is the Ukrainian-Russian war. Topic 4, not quite sure. Might have to look into that more. Topic 5 is probably, well, I see Gaza, but I also see strike and Sunak, so we might have to look at that more. Again, this is where the people using Orange are at a slight disadvantage because you don't get to see which document goes to which topic. Let's see. Yeah, these are difficult. Thankfully, this is with the BBC News data set, so the other one is actually a lot easier, the hotel one. So hopefully you have an easier time. But look through, is it talking about the cleanliness? Is it talking about, I hear noise at night and the windows let the sun in? Well, maybe that's the room environment. If the topic is front desk, housekeeping, and concierge, maybe it's talking about the staff at the hotel. They're not always going to be perfect. In this case, let's see. This one might be a little broad. Maybe that tells us that 9 topics is too many. Maybe we should go down to 5 or 6, or let's play around with it. That's where topic modeling can be super frustrating for people that really like the scientific part of data science. They like very specific things. They like things to be black and white. But if you are like me and you like to experiment and try things out, And the very fun thing, to not have to be wrong, topic modeling is for you. As long as you justify what you're doing and you kind of explain your thought process, you put some thought into it, you are going to do very well with topic modeling because it's all about taking what you see and just making good decisions with it. There is no one right way to do topic modeling. There's no one correct number of topics or one correct topic name. So that part can be pretty fun. I'm going to quickly show you the code for anyone using Python. Again, we're using the TripAdvisor hotel reviews, which is on Brightspace. Looks just like this, pretty simple. And this is all the code we've had before. All of the code, again, is provided for you. So if you run this as is, it should work pretty well. The only thing you have to change is you have to figure out number of topics and number of top words. Now, the number of top words is really just for you. How many top words do you want to print? I like printing between 5 and 10. I don't like seeing a ton. I have one research partner that made me print 50, and I had to explain, at some point we're just printing, the most popular words, that it doesn't matter at a certain point. We really just want to know the top few that are impacting our topics. So if I look here, this one I ran with 10 topics and 5 words. You implement the model here, and then it prints out. This first topic is hotel, recommend, city, located, stayed. So maybe we can say overall review. This one's resort, beach, food, pool, people. And again, maybe this one's not the right number of topics. Let's see, what's a good one? Ooh, good walk, station, location, breakfast. So maybe this one's a good one to call location. Maybe it's within a good walking distance of something, close to a train station. They specifically mentioned location here. This one, service, excellent, best, hotels, food. So maybe this one's calling out a luxury type service. Some of them aren't great. This one, I think this is half of a word, another half of a word, really like in people. So maybe I need to do more cleaning in my data set. If you get topics like this, you should definitely go back and clean your data set because this is not a real topic. You can see this other method. I did number of topics is 5, and I printed out just more words. And you can see these are very similar. So the 5 topics versus 10 is similar. Printing more words just gives us more information. And with more topics, we start grouping things together a little bit. So let's see. Yeah, this one definitely needs more cleaning. So that'll be your homework, really, if you're doing the Python, or really the orange too. Clean a little bit more. This one still might be the location one. You can see location names, beach, pool, beautiful. This one's talking about just overall experience, maybe. Oh, maybe this one's location. A lot of them are locations. All of that to say, as long as you try hard on this one, you're fine. And then this is all code you do not need to change whatsoever. I did not write this. This is credit to, honestly, one of my former, what was he? He was a classmate of mine in grad school. He gave it to my professor, who I ended up taking over the class for and teaching it years later. So that's how good this code is. I don't expect you to write like this, but we're just taking this and implementing that. So there we go. Which topics do we want to put in? So all of this code is saying, take this topic and add it to our data set. And then we can see if we implement it, here it is. So with 10 topics and 5 words, and that's really nice for when you want to look through and say, why is this review, or what is this topic? You can start to look through, oh, it's this kind of review. So short and sweet today. If you have any questions, definitely reach out, but that should be the last lecture for this term. I will be posting some extra videos just to help you through the final as I find information that you might need. As I get questions from others, I'll post the answer for everybody. Um, but yeah, enjoy topic modeling. Again, it's one of my favorites, and have a great week. Thanks. Bye.